Good morning, dear friends. I am Dr. Rajin Linus, Associate Professor and HOD of Electrical Engineering Department at Sanjay Godavat University, Kolhapur, Maharashtra. Under this electromagnetic theory, the last class we come to know how one can convert spherical to Cartesian unit vectors of uh, u r, u theta, u phi, how one can obtain. Then what will be the projection of those vector in x and y and z axis? That means Cartesian coordinate system. Under this, we have learned what is meant by u theta, what is meant by UR. In this lecture, we are going to learn about how this U phi can be calculated, what will be the projection of u phi in x-axis, u phi in y-axis, and u phi in z-axis. Also, we will convert all the vectors in Cartesian to spherical and spherical to Cartesian, especially unit vector and that the coordinates and that each component of the vectors to Cartesian to spherical and spherical to Cartesian. Let me share my screen now. I hope my entire screen is visible to you. That's what we have learned in the last class, how this u theta and how that u theta component will be. Then the third component is our u phi component, right? So we can take a new page. So again, let me draw the diagram. Uh, this is the spherical coordinate. We have this x-axis, y-axis, and z-axis. We have assumed this is the point. Let me take another one color. This is the point. So this point is distance of ur vector along the direction. This is will be r. Then we have another one component. It will be this is u phi, u theta we have done. Then another one related to this blue color. This will be our unit vector along the direction of theta, along the direction of r, and another one along the direction of this circle. Along the direction of this, we can make it one cone. We can make it so this will be theta, right? Then we can have then this is r, and this point of projection in this plane. So this plane will be, we can say that phi. So phi is varying like this. That means phi will be this way, phi unit vector along the direction of unit vector. So now, if you take this in this xy plane, this unit vector will be like this. Unit vector along the direction of increasing phi. So this is the unit vector. So what are the components in this unit vector? If you carefully see, this is, if I will take only xy axis separately so that you can easily understand. This is x axis. This will be y axis. The x axis. This is the y axis. Then we have, this is the angle phi, and this will be the unit vector u phi gap. So what are the unit vector component? This unit vector have the component of, unit vector have the component towards this x-axis, towards this y-axis. So this is our x-axis component, this is our y-axis component. So this angle is phi, automatically this angle will be phi. So now you can see this. This angle is nothing but phi, right? So we should understand this. We know that magnitude of u phi gap is equal to 1 since this is unit vector. So you can take one point, this is O and this will be A, this will be B. We want to know what is OA and what is AB. So what we can write, sine phi can be written as OA divided by OB. So we can have OA equal to OB, already know unit vector along the direction of u phi. So magnitude will be 1. Therefore, OA equal to sine phi into 1. Similarly, AB, the cos phi, we can write it as cos phi. Cos phi can be written as AB divided by OB magnitude. Already we know magnitude of OB is nothing but magnitude of unit vector of U phi. Therefore, which gives AB is nothing but we can have it cos phi into 1. So already we know U phi gap is nothing but we can OA vector plus AB vector. What is OB vector? OA vector. OA vector magnitude you can take it as OA vector sine phi, right? Then AB vector magnitude you can take it as cos phi. But the direction of this OA is opposite of x-axis. This is x-axis towards this direction. So unit vector along this direction will be I gap. Unit vector along the direction will be j gap. Therefore, this is opposite to that OA. So that what happened minus I. So we can write it as OA, already know the magnitude sine phi minus I vector. So I am writing here minus this side plus cos phi along this direction will be j vector. Therefore, we can write it in j form. Now, we can write all those vector in matrix form u theta u phi. Let me take, this is another one equation from this conversion of phi. So this, the three equations are main equations to form this matrix. What are the matrix? In the previous lectures we come to know that, that here this is the one main vector, equation. Since u are in terms of ijk, then we can have it, yeah, u theta. This is another one main equation, and third equation will be u phi equal to, this is our third equation. So from this we can write in matrix form. Already I can, let me write it, summarize once again. U r gap equal to sine theta into cos phi into I gap plus sine theta into sine phi into j gap plus cos theta into k gap. Then u theta gap is equal to cos theta into cos phi into I gap plus cos theta into sine phi into j gap plus minus sine theta into k gap. Then u phi gap is equal to, you can write it from here, minus sine phi into I gap plus cos phi into j gap plus 0 into k gap. There is no vector along the direction of k. So if we write it in matrix form, we can have ur gap, u theta gap, u phi gap is nothing but, we have this matrix sine theta cos phi, then sine theta sine phi, then cos theta, then cos theta cos phi, then cos theta sin phi, then minus sin theta, then minus sin phi cos phi 0 into the matrix can be written as I gap, J gap, and K gap. This is the matrix which we can derive from this. So this is the conversion of vectors, unit vectors in Cartesian to unit vectors in cylinder, in the spherical coordinate system. So first we should know what will be the matrix when we take this I. How we will convert Cartesian to then the spherical to Cartesian coordinate. For that, you take this matrix is C matrix. You take this matrix alone, C matrix. So if you take this determinant of this C matrix, you can see sine theta into cos phi into 0 plus cos phi into sine theta minus sine theta into sine phi into we can have minus sine phi sine theta plus cos theta into cos theta cos square phi plus cos theta plus cos theta into sine square phi. So from this, we can write it as determinant of C matrix is nothing. Determinant of C matrix is nothing but sine theta sine square theta cos square phi, then plus sine square theta sine square phi plus cos theta cos theta cos square theta into cos square phi plus sine square phi. So this cos square phi plus sine square phi we know 1. So if you take this sine theta, you can take from here sine square theta outside. Therefore cos square phi plus sine square phi plus cos square phi. So this magnitude will be 1. Then finally sine square phi, sine square, so this is sine square theta. So sine square theta plus cos square theta equal to 1. So determinant of C matrix is equal to 1. Therefore C is orthogonal matrix. So if this C is orthogonal matrix, what we can do, C matrix, already in the last class I have explained, C inverse is equal to C transpose. Therefore, if you want to convert this matrix into IJK, if you want to know this variable IJK, just to take this inverse of C this side, so you can take this transpose of this matrix, then finally we can write this equation in this IJK. Let me copy this entire matrix what we have done, so that you can understand. So we have, this is the C matrix. So we can write I vector, I gap, J gap, K gap is nothing but, so C inverse equal to C transpose. Therefore sine theta cos phi. Then I am writing this all rows in column. So sine theta sine phi and cos theta. Then I am writing this rows again column, cos theta cos phi, cos theta sin phi and minus sin theta. Then next row minus sin phi cos phi 0 into u r gap u theta gap u phi gap. This is what we can write it all the vectors in this equation will implies Cartesian to cylindrical spherical. This will give spherical to Cartesian this unit vector alone. Then let me explain how one can derive this equation for all other vectors. We know already a we can have a x equal to we need to find out a vector is nothing but ax in Cartesian coordinate, ax in the I gap plus ay in the j gap plus az in the k gap. Then this is for Cartesian coordinate system. Then spherical coordinate system, what is that? A r in the UR gap plus A phi in the U phi gap plus A z in the U z gap. A phi in the A z in the U z gap. Therefore, we can write this as we can spherical coordinate system. Now we come to know how to convert I to UR, how to convert J to U5, how to convert this all the unit vectors in between these two. How we can convert in both directions. Now we should understand how we will convert AX to AR, how we will convert A5 Y to A5, how we will convert AZ to A. This is AZ, this is not AZ, this will be A theta in the U theta. So how we will convert AZ to A theta. But other things we have already learned from this previous matrix. So for that, what we have to do, AX component, we assume that we have that component A vector is AR in the UR gap, A phi in the U phi gap plus AZ in the sorry, not A is in spherical coordinates, A theta in the U theta gap. This is the equation in Cartesian coordinate system. So now that component, I want to know what is AX. What is AX component? This A vector component along the direction of projection of A vector in I axis. So that we will call it as AX component. Then A vector in J axis. Then A vector in A vector in K axis. So if you do that, we know what is A vector. We know AR equal to then this is the AR in the UR plus A phi in the U phi plus A theta. So we can substitute here AR in the UR gap plus A phi in the U phi gap plus AZ in the U. So every time I am using this, don't be confused. A theta into U theta gap dot I gap. Now we have that component. What is AR? Let me take another one bracket. AR. What is UR in terms of IJK? Already we have derived UR sin theta in sin theta cos phi, sin theta sin phi, cos theta, right? We can write UR sin theta sin theta. Let me take sin theta cos phi, sin theta sin phi. Sin theta cos phi in the I gap plus sin theta sin phi in the j gap, sin theta sin phi in the j gap plus sin phi in the j gap plus cos theta into k gap plus cos theta into k gap. Cos theta into k gap plus a phi. What is a phi? A phi into what is u phi? U phi is nothing but u phi can be written as u phi, no, u theta, okay, u theta u phi or okay, u phi can be written as this matrix. So I will take this copy entire matrix here so that we can reduce the time consuming. So minus I, just I have written in the I, this will be we can write j gap and this will be k gap plus then another one component. Uh, this is sine theta a phi into sine theta component sine phi cos phi 0. So minus sine phi cos phi 0 plus a theta component into we have again the variable a theta component into u theta. U theta component you can take it from this. We can copy this. Let me write this. Okay. Component with cos theta cos phi sin cos theta sin phi. So you can paste it here. Cos theta cos phi plus sin theta sin phi into j vector. And then we can write this one dot I gap. This is I gap, right? So this is I gap, I am writing. So I gap. So when we do this dot product, I dot I to 1, at the same time I dot j, j dot I, j dot k, all those things are 0. So these two parameters will be 0. This is I think j, so this will be 0. So we can have a x equal to sine theta ar into sine theta cos phi plus cos phi plus I dot I is equal to 1, then minus we can have a phi a theta I vector, yeah, then we will write it a theta into cos phi into cos theta, then plus we can have minus a phi into sin phi, a phi into sin phi. Similarly, you have to find out a x I given to you. You can do as a homework. A y equal to a vector dot j gap and a z equal to a vector dot k gap. So that when you do this, instead of this you can write it j. So you will get this jj component and ik component will be 0. Similarly, when you do this a vector dot k vector, only you will get k component, ij will be 0. So like that, we will get one equation. You can write it in matrix form. What is that? Ax, ay, az matrix is equal to sin theta cos phi minus cos theta cos phi, sin theta cos phi minus cos theta cos phi. Then we can have minus sin phi. Then we can write it this equation finally. This equation, when you do it ax, ay, ax component, we can have sin theta cos phi and sin theta sin phi and cos theta. Then similarly cos theta cos phi, then cos theta sin phi, then minus sin theta, then minus sin phi and cos phi 0 into AR A theta A phi. Like that, we will get this answer. Let me, otherwise, I think we have chosen this coordinate in this different way. You can do this. You can do this also. Otherwise, then if you want to know AR, A theta, A phi, what we have to do, you no need to do this conversion matrix. You no need to do that matrix, just inverse. This is orthogonal matrix. So this orthogonal matrix, you know, as inverse is equal to transpose. Therefore, I can write it now, sine theta cos phi, then cos theta cos phi, then we have we have minus sine phi, then we can write it as a theta equal to, then write this row column wise, sine theta cos theta, then we can write that sine theta sine phi, then cos theta sin phi, then we can write cos phi, then cos theta minus sin theta and 0. Cos theta minus sin theta 0 into, we can have this matrix AX, AY, AX. Ax, Ay. This what we have to derive this equation. How this all the vectors now we have converted into Cartesian coordinate. All the uh, vectors of unit vectors u r, u theta, u phi. How we have converted into Cartesian coordinates. Similarly, vice versa. Similarly, all the components of Ax, Ay, Az, how we have converted into AR, AX, A theta we have learned. I hope this is understandable, and you can easily grasp the knowledge about how one can convert Cartesian to spherical, spherical to Cartesian. I hope these lectures are very much helpful. Those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.